Hello, I'm Nikhil, and today I'll be talking about my paper on Faux Polyglot, a study on information disparity in multilingual large language models. But before I start, let's take a step back and let's look at the complexities that are encountered while information seeking in a multicultural world. When I search for a query, I expect a model to respond me with a correct answer. This setup does not look too complicated until you start to consider that people from different cultures can ask the question in different languages with different priors. And the information is in the web is present in different languages containing conflicting information. Now, this setup is starts to become a little more complicated. And what the correct answer is starts to become a little more obscure. So to understand how LLMs retrieve and generate information during these information conflicts is crucial. It's crucial because giving the users different information would cause information disparity, which would lock them in filter bubbles, hindering constructive communication and even fracturing the fabric of society. So to understand the behavior of LLMs, we ask three research questions. First, how does the language of the query affect the retrieval and generation preferences of the LLM? The second research question we ask is how do the preferences change depending upon the type of query asked? And finally, we ask how do these preferences change if none of the articles are present in the language of the query? So let's take a look at the setup. In this paper, we use the RAG setting, which is the predominant way to use large language models for conversational search. In RAG, there are two phases, the retrieval and then the generation. During the retrieval phase, a retrieval model retrieves and ranks documents from an external database. There are different strategies to rank and retrieve information, but for this paper, let's just focus on cosine similarity because it's the most popular method currently in use. A subset of the top-ranked documents based on the context window of the large language model are then sent to the context of the LLM. The LLM then uses this information in the context to provide an answer. If you remember the research questions, we wanted to study the impact of the type of query and the language of the query on the final answer. But as you can see in the figure, the final answer is dependent both on the generation and the retrieval phase. Moreover, the generation phase is directly impacted by the quality of the retrieval. Hence, in the study, we'll study both the retrieval and the generation independently. But to answer our research questions, let's add a bit more detail in the setup. So we have a question that can be in different languages and it can have different priors, as we saw in the first example. Now, for the data set, we need multiple documents in different languages that contain conflicting information. We could source the document from the internet, but the guardrails do not work equally across different languages. And the parametric knowledge or the knowledge gained during pre-training can affect the answers and and hence we decide to use a more calculated approach, designing our own synthetic topics and documents and questions to remove these confounders. So, looking at the coverage of topics across the world, particularly looking at information conflicts, we found that the documents had some overlapping facts, a few contradicting facts, and some exclusive facts only present in that article. Finally, there were also articles that had similar facts but presented them differently, with different perspectives. We created articles that exhibited these conflicts and called one set of documents the original and the other set that contained conflicting information as the alternate. And so we designed two premises, the festival premise dealing with factual inconsistencies and the war premise dealing with diverse perspectives. The variables inside the curly brackets are unique entities, not present in Google and ChatGPT, which we ensure by querying ChatGPT and Google about these entities. This is done to ensure that the parametric knowledge of the LLM does not confound our results. All of these documents were then translated into five languages: English, Hindi, German, Arabic, and Chinese. In the end, we ended up with 170 languages across all the languages and premises. For the festival document, we created 135 factual queries and across the five languages. And for the war premise, we had 80 opinionated queries across five languages. More details about the creation of the dataset and the further correct categorization of the queries are in the paper. Now, let's take a look at some of the highlights of our results. During retrieval, we found that 68% of the documents were from the same language as the query, which we'll refer to as native documents. And the native documents had an average normalized cosine similarity score of 1.03. Compare that to the foreign documents, which had an average cosine similarity score of just minus 0.25. These results are based on 170 documents. And you can imagine if we scale this data set up, it is possible that among the top 10 articles, 100% of them would be in the native language of the native language documents. And the context of the model will not encounter perspectives from foreign documents. We further analyze these results with different query types, looking at the preferences of foreign documents when there are no native documents. The results of this experiments are in the paper. Now, assuming that we have a perfect retrieval system, that gives us balanced documents to the language model. Let's take a look at how the generation phase handles these diverse perspectives. Looking at the aggregate preference scores, we see that the answers were derived from the native language documents 42% of the times. Compare that to 29.58% for foreign language documents. Only 8.55% of the documents contain information from both the sources, and for 19.8% of the answers, they came from neither of the sources. This indicates that the model systematically preferred generating answers from the documents in the same language as the query, even when the diverse facts and perspectives are available in the context. Furthermore, we also found a troubling trend of English being the dominant foreign language, and a trend where the higher resource languages such as English, German, and Chinese scoring higher than lower resource languages like Hindi and Arabic. We also analyzed the trends across different types of queries, which are presented in the paper. Overall, this leads to a troubling conclusion. LLMs are for polyglots. And summarizing the result, let's take a look at the hypothetical scenario inspired by real ChatGPT responses. We have 3 users from different regions. All of these users are interested in learning about the conflict of India and China. When a user from India searches for the query, they search about the war in Hindi, and they get back results that reflect the biases present in the documents of Hindi. And similarly, for the Chinese user, they get back the results that are only represent the perspectives of the articles present in Chinese. But for the Arabic user, there are no documents in Arabic. So they are getting the American perspective because that is the highest resource languages. Finally, after the information seeking session is done, all 3 users come up with completely different understanding of the war, and there is no common ground. This is information disparity. Let us look at the troubling social implications and how we can potentially navigate these for polyglots. For polyglots, lock users in filter bubbles, and the persistent failure of models to transcend linguistic barriers ultimately jeopardizes the common knowledge necessary for democratic stability, leading to mass persuasion tactics and the control of narratives in a few people's hands. For polyglots are a new challenge for information literacy in conversational search. We need to educate users to know the limitation of these systems and create scaffold to support diverse information seeking. If a user wants the complete picture about a topic, the only solution from their side is to query the issue from multiple different perspectives in multiple different languages, which is an impossible task. Hence, as a research community, we need to work towards creating scaffolds for users, like aggregating responses from multiple personas, retrieving diverse perspectives from multiple languages, and issue warning to users getting logged in confirmatory queries and responses. We also need programs to increase information literacy around conversational search, reducing potential issues like overtrust and reliance on information presented by these models. Finally, we also need to understand fog polyglots better. We need to look at the effects of different training strategies, data mixtures, and RAG architectures. Furthermore, we also need to look at how the cultural differences can add to the observed effects of linguistic preferences. I hope we can all work towards fixing multilingual LLMs and RAG pipelines so that they can do what they promised, breaking the language and cultural barriers to better enhance knowledge access across the globe. Thank you.